platformed off of the GeoNex 610 rig. The platform itself is an exciting piece of technology. The methodology itself has been with our company, and the experience that we've developed with that paired with this new platform is really rather exciting. In essence, the DTH technology allows us to go through consolidated mixed materials and other challenging geological conditions that traditional auger boring, pipe ramming, and jack and bore technologies struggle to overcome.
The GeoNex 610 rig.
The fact that it can also work
itself
in
an exciting
subsurface water conditions really makes it ideal for so many different projects that really are challenging with the traditional methodologies.
Is really rather exciting.
What we'd like to do today is show you some of those functions.
In essence, the DTH
talk about
allows
the
us
technical
to go through consolidated mixed
and
materials,
some of the capabilities of the machine,
other challenging geological
and
conditions
then
that
move to that live demonstration so everybody can kind of
jack and bore
get a sense of what this machine is actually capable
struggle
of.
to overcome.
I'm going to let Elliot speak to some of the technical. This is Elliot Brown. He's really Vice President of Operations of the tunneling company based in Kamloops, British Columbia.
Challenging with the traditional methodologies is really rather exciting. What we'd like to do today is show you some of those functions.
In essence, the DTH
technology
allows
the technical
consolidated
materials, some of the capabilities of the machine,
other
challenging geological
and then
that
move to that live demonstration so everybody can kind of get a sense of what this machine is actually capable of.
To overcome.
I'm going to let Elliot speak to some of the technical. This is Elliot Brown. He's really Vice President of Operations of the tunneling company based in Kamloops, British Columbia.
Challenging with the traditional methodologies is really rather exciting. What we'd like to do today is show you some of those functions.
In essence, the DTH
technology the technical consolidated materials, some of the capabilities of the machine, other challenging geological conditions that move to that live demonstration so everybody can kind of get a sense of what this machine is actually capable of. I'm going to let Elliot speak to some of the technical. This is Elliot Brown. He's really Vice President of Operations of the tunneling company based in Kamloops, British Columbia. Challenging with the traditional methodologies is really rather exciting. What we'd like to do today is show you some of those functions. In essence, the DTH technology the technical consolidated some of the capabilities of the machine, other challenging geological conditions that move to that live demonstration so everybody can kind of get a sense of what this machine is actually capable of. I'm going to let Elliot speak to some of the technical. This is Elliot Brown. He's really Vice President of Operations of the tunneling company based in Kamloops, British Columbia. Challenging with the traditional methodologies is really rather exciting. What we'd like to do today is show you some of those functions. In essence, the DTH technology the technical consolidated some of the capabilities of the machine, other challenging geological conditions that move to that live demonstration so everybody can kind of get a sense of what this machine is actually capable of. I'm going to let Elliot speak to some of the technical. This is Elliot Brown. He's really Vice President of Operations of the tunneling company based in
pulverize the rock formation in front of us. This methodology is it's really good at drilling both solid rock and mixed ground conditions where boulders are present that would pose a problem to traditional auger boring and pipe ramming. So yeah, I think what we can do here is I'll just pass the mic over to Dane, and we'll get our compressors fired up here, and it's set up the windscreens and stuff like that, and we'll get to drilling.
Does anybody have any questions? While we get ready, I can point out a couple other key features of the equipment. Unlike traditional auger boring or pipe jacking, this equipment doesn't require a reaction wall. So in essence, you don't have to come in with as robust a setup. A thrust block traditionally for pipe jacking can be fairly competent because of the native ground materials requiring a larger reaction surface. So with this equipment, because it's self-motivating, meaning that the hammer inside the lead section of pipe actually pulls the casing through the ground rather than in a traditional auger bore or pipe jacking where you're applying that static pressure from the rear of the casing. The hammer itself draws the pipe into the ground. With this equipment, while it can push, we're essentially just keeping up with the hammer to close the trip valve inside. So that does allow us to overcome some of those other components with a traditional jacked pipe. This system can actually break down significantly to shorten the platform, and there's actually an extension that can lengthen it as well, depending upon site conditions, the size of setup area. So it can condense that footprint quite a bit based on access and available space on site. And because it doesn't need that reaction wall, it again can fit in a tighter footprint.
Probably a good idea to get the ear protection put in.
Yeah, this is a good time to put your ears in.
We have that compressor fired up?
Do you want to do the up, down, left, right?
Yeah, sure.
So one of the exciting features of GeoNex is with a lot of auger boring, you have to have a finely graded excavation. Everything is built off of a surveyed and kind of a graded pit. One of the cool things about the GeoNex platform is you can actually set it on, and as you can see behind me, it allows for articulation of that table so that we can achieve the angles and alignment. One of the typical problems with traditional open-faced auger boring and pipe ramming is as you move through different geological situations, say running from consolidated material to flowing material or even groundwater conditions, you can have unmitigated inflow of material into the casing. One of the benefits of the GeoNex system and DTH technology in general is as you transition from non-flowable to flowable ground conditions, it really reduces that risk where you would have siphoning or uncontrolled movement of material into the casing. So it kind of self-regulates and prevents that that siphoning feature that you get with a lot of open-faced methods. So typically you would use something like an SBU or a rock boring unit, which are excellent methodologies in and of themselves, but this overcomes some of the key parts that can really hold you up in that methodology. So I think we're good to go. So what you saw him do is essentially the process of collaring into that material. The reason why he's going so slow and deliberate is that's really how you engage and keep that line and grade in this consolidated material. So if you're slow and deliberate when you start that, it really gives you an opportunity to hold that line and grade as you launch. So as you see, he's collared in and really had a good face start. Do you want to describe that a little bit?
Yeah, sure. Have you covered the drive shoe in the
Only a little bit. You can.
Sure. Okay, well, it might be a good time to stop and just kind of explain a little bit of what you saw there. So the downhole hammer in the leading edge there, as I mentioned, it strikes the pilot bit, which drives the pilot bit and ring bit into the formation, which penetrates the ground. It's also the pilot bit serving a second purpose, which is to strike the shoulder of a drive shoe that's also located in the leading edge of that pipe. And that's what advances the casing as we drill as well. So yeah, essentially the casing is getting pulled through the ground instead of jacked through the ground as it would be on like a conventional auger bore. Does anybody have any questions about anything you've seen so far? All right, we'll send it. Sure. Yeah, it's that's a bit of a loaded question. Sorry, what's that? Oh, okay. Repeating the question, it was pertaining to advancement rates on this. So yeah, as we mentioned, we collar in very slow and make sure that we establish the correct line and grade and get the surrounding ground to essentially support the pipe on that design alignment. The advancement of the pipe, kind of once we get into the ground, on a 16-inch crossing, you're likely in the neighborhood of, I would say 40 to 60 feet a day working in 20-foot sections of pipe. It's a very loaded question, though. It really depends on the ground that you're going through. Yeah, absolutely. Yeah. Yeah, so essentially 6-inch to 48-inch is the capabilities. This rig here will do from 16 up to 30, and then we have a few rigs that are larger than this one that take it from 30 all the way up to 48-inch diameter. There any other questions? Sorry, I can't. No, actually, that's worth mentioning as well. We don't typically use any sort of drilling fluid. What you're seeing come out of the augers there is just water for dust suppression. In clay formations and swelling clays and things that will put a lot of skin friction on the pipe, you can mix a polymer solution to run through the hammer to help lubricate the hole that's being drilled. But not typically. We don't necessarily go to those. Sorry. Oh, right. So for drilling crossing lengths, we're usually in the neighborhood of 320 feet for this technology. It can go farther, and it has, but the variable that kind of limits that is the integrity of the drive shoe. And also like the geotechnical conditions, of course, yeah. Yeah, okay, so maintaining steerability. Everything, this is an unguided methodology, so everything is essentially pit launch. We line everything up on crossing alignment or design alignment. We survey everything before we start, and you'd start it very similar to an auger bore or a pipe ram, where you'd be down there checking it with a smart level and shooting the pipe, let's say every 3 feet of advancement on the first casing. And then typically once the ground has it, these do drill fairly straight. If you can imagine, because the downhole hammer's energy is basically, it's all concentric with the pipe that it's pulling, and things that like on an auger bore or a pipe ram methodology that would push you off of alignment, this tends to core through. So there's a lot of energy at that leading edge that helps it go a little bit straighter than a typical auger bore or pipe ram. Typically, we like to say up to 300 feet on this diameter, we'd be within about 1% radially. of design alignment.
Can you advance the drill through a watertight adapter ring like you would an ice ring?
Yeah, like a ground seal, you absolutely could. There's no issues with that. These are used in vertical application in marine construction all the time for doing piles and things of that nature. So from a methodology standpoint, it's doable, but again, like things you have to consider are the water pressure in the ground and things like that.
There are water retrievals that we've done.
Yeah, we have done water intakes with these as well into lakes and essentially block the end of the pipe off when we poke out with a test ball or something of that nature.
Okay, follow-up question. You can advance some of these under the groundwater table, right?
Yeah.
How much inflow can you expect through the... Repeat question, please.
Okay, so sorry, I keep forgetting to repeat the question. Basically, how much groundwater we can expect to see through the pipe. You'll notice maybe once we pull this thing back through, we can kind of open up the floor here, and you guys can have a look at the pilot bit a little closer. Essentially, there's 3 small ports in the middle of it that distribute air, and then there will be about 3 or 4 probably 2-inch by 2-inch ports radially around the pilot bit that are used for flushing soil and cuttings back to the auger. So again, depending on the pressure and the amount of water that you're in, it's a lot less than you would see in like a open-faced pipe ram or auger bore situation. One more here.
So then based on that, do all the spoils come back into the hole, or do they get displaced?
Yeah, okay, so sorry to repeat your question. It's about where the soils go when we drill. So yes, I should have mentioned that before we started here, but basically once we push into the ground, the ground creates a positive seal around the pipe, and then all of the air pressure that the pilot bit exhausts is then flushed back through the ports, and that carries the ground cuttings with it. So everything gets fed. As I mentioned, there's a downhole hammer in the leading edge of that pipe. Everything essentially gets pushed by air pressure past that downhole hammer and then into the augers. And then the augers that rotate expel the material back to the entry pit where it's mucked out and removed from the entry pit. Anything else? Right on. Okay, we'll drill a little bit more here, and then we can kind of pull the tooling back, and maybe what we'll do is we'll just shut everything off and give you guys the floor to kind of come have a look at some of this stuff.
So we're going to get everything kind of idled down here in a second, get it shut down so that everybody can kind of take a look. There's a little bit of water, so, I mean, apologies for the mud, but we're out here to get a little bit dirty. Just give a couple minutes to get everything idled down. Because, obviously, for safety, we didn't want to throw all the air to it that it's capable of doing. This is a very slow collar-in process that we did. The ability for this thing to advance through this material, once he's collared in, that advancement rate goes up critically, like a lot more. So in the interest of not creating fly rock and creating that hazard, we just took it very slow. So again, give us a couple minutes to get everything safed out, and then everybody can take a look and ask some more questions.
Hey, Dane, did you want to know who's opening it up?
While this is idling down, did anybody have any other questions that they wanted to ask? All good? All right. There's coffee, water. If anybody needs anything, please let us know. It'll just be another minute or two, and then we'll... Yep.
So say you go through some hard material like this, and then you hit your clays or whatnot. So do you just flush all this clays to the auger and auger it back?
So the question is, if it changes ground conditions from consolidated to a clay material, would it still digest that material and bring it through? It does. All of the material or those cuttings, that in that case, if it doesn't displace it, it does digest it and it does bring it out on the auger flights.
And that's just, is it done by the air or is it done by the water?
So there is a short period around the hammer inside the casing that is unflighted. At that point, the motivation of that material through that section of the casing is done by the air pressure, shifting that material back, and then the flights carry it the rest of the way.
Is there a directional version of this?
Horizontal directional drilling does have an uncased, and the question was if there is an HDD version of this tooling, correct? Or a directional drilling application for this methodology. There is a horizontal directional drilling uncased hammer that is used in much the same fashion, whereas this can go from different geologies where it's consolidated, unconsolidated, with the cased application because it maintains a path for those cuttings to make their way back out of the hole. The directional drilling tooling requires consolidated material so that it keeps that channel open to bring that material back out of the hole. There are advances in the technology that are coming out that we're staying on top of that could potentially give us the ability to steer a little bit, or at least manage the line and grade. But typically right now, most of the DTH methodologies and purposes and projects that we've undertaken don't require that steering. Yes?
It's probably a dumb question, but if the drill bit is inside that pipe that you're ramming through, then the drill bit is smaller than the pipe itself. So how are you also pushing the pipe through? Is it just hydraulic pressure breaking that last little bit of the hole?
Yeah, let me give Elliot that.
Yeah, okay, so the question was, if the drill bit at the leading edge of that pipe is smaller than the casing pipe, how is it essentially pulling a casing pipe through it? And that's a good question. We can have a look at this actually. On the leading edge here, there's an interlocking ring bit that couples on the, once the pilot bit and hammer is slid through the pipe to the leading edge, it will protrude past the leading edge of that starter casing, maybe 2 inches. And then there's a ring bit that overcuts the OD of the pipe very precisely, that grooves, like some of them are kind of latch and groove style, and some of them have helical threads that fix the ring bit to the pilot bit, and that's how it overcuts the pipe as well. That depends. Like, you can get them custom designed for whatever tolerances. Typically, like a standard casing advancement system would have between let's say 3/8 of an inch to 5/8 of an inch. Like, a lot of the times when we're doing these for oil and gas pipelines, for slip bores, say, we'll DTH using a larger outside diameter so that the casing pipe stays free in the ground and can be slipped through easily. So, any other questions?
That's on the radius?
Yeah, that's 3/8 to 1/2 inch radially. Yeah, you bet. Yes.
So since you don't have a thrust block on the back of this pushing against your shoring system, if I want to go from pit to pit and shoot up an angle or shoot down, can it do that? And what kind of degrees do we have?
Yeah, absolutely. So the exact number, I think it's around 10 degrees of adjustment in the hydraulic leveling platform. And yeah, you can aim uphill or downhill. Downhill is typically our preference with these. Just it helps to prolong the life expectancy of the drive shoe at the front without having to pull the weight of the casing uphill with it and put that burden on the drive shoe.
Can you adjust the bottom right to just the hydraulic to 10 degrees? So if we sloped it, you can go more than less than that?
Yeah, pinch.
Yes, absolutely. They are used in steeper application all the time, and you can pre-grade a earth ramp or a pit for the machine to sit on to achieve steeper angles in both directions. Yes.
So once we get pit to pit and we're putting in the product pipe, typically for a hammer bore and auger bore, we'd slick line the product pipe in. What's actually interfacing with the product pipe? Are you pushing against it with the ram back there, the carriage?
No. So everything. Sorry, just to repeat your question there. So you're asking how the product pipe is then slipped in a slip bore configuration. So the leading edge of that starter casing has an inside drive shoe which protrudes on. It decreases the ID of that casing by about 1.5 inches all the way around, and the shoulder of the pilot bit actually strikes that. So as you hear that hammer hitting, it's making contact with that drive shoe, and that's essentially what's pulling the casing through the ground. That's why we don't need a jacking frame. All of this stuff is all the magic is kind of happening at the leading edge there.
So once the drive through is through the other side of the pit, though,
Yeah.
you've got jacking pipe all the way back.
Oh, I see where your question is. So how do we slip that pipe in? So this rig here will, this one here I think is around 100,000 pounds of thrust, and if you had to, if it took more jacking force to move the pipe, we would probably just bring in a hydraulic auger boring machine to slip it after.
Okay.
But the alternative to that too is you could increase the overcut spec on the downhole hammer system to make sure that you can keep it at a reasonable level. Any other questions, or should we open up the floor here so you guys can kind of have a look at the pilot bit and the system a little more closely? Right on. Okay, well, we'll open it up. You guys can kind of enter through here and have a look at things. on the ground right next to the. So that's the ring that we talked about that overcuts the bogey of the pipe. If you come up here, you can kind of see because there's a lot of thing too on the pilot pin as well. Maybe that's better if we can a bit advancing the basic pipe.
More reaction back.
Yeah, feel free to come up and have a look if you want.
So they're going to kind of leave it there and then say, okay, we're done.